Let's take a look at projectile motion. Projectile motion is a motion of an object in two dimensions, and the only force that is acting on the object is the gravitational force, or we also know it as force of gravity or weight. And the symbol we use for gravitational force is F of g, and it's always going to be pulling the object in the downward direction. Now, I've seen this case before in free fall, but there is an up and down motion, and there's also a left and right motion, so this is how it is different from the free fall motion. In projectile motion, it's also an example of free fall, but it's in two dimensions. Let's take a look at an example of an object thrown in the air, and it's coming back to the ground, and it's following a curved path. At each point on the curve, the force is going to be the gravitational force only, and the acceleration is 9.8 meters per second square downward direction. Now, when we analyze the projectile motion, the key to remember is that projectile motion is in two dimensions, which means that we have to look at the velocity in two directions, the x and y direction. But keep in mind that the velocity is changing at a constant rate, and that's how we can see the acceleration of gravity is 9.8 due to the gravity. Now, the key that we are going to summarize to solve projectile motion is to break it down into two parts. One is going to be the horizontal part, and the other one is the vertical part. So when we look at the horizontal parts, we're going to look at all the variables only in the horizontal direction. When we're looking at the vertical parts, we're going to look at all the variables only in the vertical direction. And that's how we're going to treat them separately and then solve the problem to find the unknown quantities. So let's take an example of, let's say we have an object thrown in the air again, and it has followed this path, and we're going to analyze the motion of this object. We already know the gravitational force is the only force in the downward direction, and the acceleration is 9.8 meters per second square. Now, if we look at it horizontally and vertically, we can break it down that since the only force is vertical force, so it means that there's not going to be any horizontal force. Whereas the vertical force is only F of g. If you look at the acceleration, since there's no net force in the horizontal direction, it means that there's no horizontal acceleration either. Whereas since the vertical force is only the gravitational force, it means that it has to have some acceleration, and the acceleration we know is equal to 9.8 meters per second square. Now, look at the subscripts that we are using for x horizontal and y vertical. Now let's take a look at the velocity. If the acceleration is 0, it means that the velocity is constant or is not changing, whereas the vertical velocity is changing at a constant rate, and that rate is 9.8 meters per second square. Now let's talk about another term that we often use for a projectile motion, which is trajectory, and it's the path of the projectile. Usually in projectile motion, the path that the object takes is in the form of a parabola. At any point, if you look at the velocities, it's always going to be tangent to the path. So if you look at these 4 points that I have on the picture, we can draw the tangent to those points, and that will represent the velocity of the projectile or the object moving in a projectile motion. And we can also break it down into its components, horizontal and vertical, and as you can see, the horizontal remains same, but the vertical is changing and also changing its direction. So tangent is parallel to the path or the curve, and that's going to represent the velocity as tangential velocity.